They're some of the most powerful forces on Earth, these massive, swirling engines of wind and rain. But have you ever wondered how they actually form, or what's going on deep inside one? And maybe the biggest question of all, how is our changing world making them even more dangerous? Well, let's dive in and break down the anatomy of a tropical storm. Okay, to get a sense of the scale we're talking about here, just think about this number, 100. Yep, that's roughly how many tropical storms pop up across the globe every single year. Now, thankfully, most of them don't turn into monsters or even make it to land, but still, it just goes to show you how common these things really are. So, here's what we're going to cover. First, what's in a name. Then, we'll get into the recipe for a perfect storm. After that, we'll take a trip inside the spinning giant, uncover its deadliest weapon, and finally, take a look at what a warmer, wetter future might mean.
All right, let's kick things off with the basics. What do we even call these things? I bet you've heard a few different names thrown around, right? Well, it turns out they're all talking about the exact same phenomenon.
It really is all about location, location, location. See, if one of these storms forms in the Atlantic, we call it a hurricane. If it's over in the Western Pacific, it's a typhoon. And if it's spinning up around the Indian Ocean, it's a cyclone. It's the same exact storm, just with a different local name.
Okay, but what about the individual names, like Katrina or Sandy? How do they get those? Well, the World Meteorological Organization has a whole system for it. The names go alphabetically, they switch between male and female, and the lists get reused every 6 years. But here's a cool fact. If a storm is especially devastating, they actually retire its name forever. It's kind of like a sign of respect for the damage it caused.
So, how does one of these giants even get started? It's not just random, It actually takes a very specific set of ingredients all coming together at the right time. You could almost call it the perfect storm recipe.
Okay, so there are 3 things you absolutely have to have. First ingredient, warm ocean water. We're talking at least 27 degrees Celsius. This is the fuel, okay? It causes this massive evaporation that rises up and forms storm clouds. Second ingredient, you need low wind shear. That just means the wind is nice and stable. If it's too gusty and all over the place, it'll just rip that fragile baby storm apart before it can grow. And a third, final ingredient, the Coriolis effect. That's just the spin of the Earth itself. It's what gets the whole system rotating, counterclockwise in the northern hemisphere and clockwise in the southern. And hey, fun fact, this is also why storms can't form right on the equator. The spin effect there is basically zero.
And just to give you an idea of how warm that water has to be, 27 degrees Celsius is basically warm bathtub water. To put that in perspective, the sea around the UK in the middle of summer, it barely gets to 16 degrees. That huge difference in temperature, that's where all the raw energy comes from.
So we've got our ingredients, but how do they come together to build that incredible, massive structure we see from space? Come on, let's take a journey, starting from the outer edges and going right into the very heart of the storm.
First off, just try to wrap your head around the sheer size of these things. A typical fully formed tropical storm can be 300 kilometers wide. That's big enough to swallow some small countries whole. Just incredible.
So, if you were approaching a storm, the first thing you'd run into are the rain belts. Think of these as the outer bands. This is where you get to first clues of what's on its way. Some rain, some gusty winds, but it's nothing compared to what's waiting for you closer to the center.
And then you hit the engine room, the eye wall. This, right here, is the most violent, most destructive part of the entire storm. We're talking clouds towering 13 kilometers high, absolutely torrential rain, and winds that can scream past 160 miles per hour. This is where the storm's raw, untamed power is truly unleashed.
But here's where it gets really weird. If you could somehow punch through that eye wall, you'd find yourself in one of nature's strangest paradoxes, the eye. It's this 50-kilometer wide hole right in the center, and inside, the sky can be clear, and the winds are calm. It's this incredibly eerie piece, and it's created by dry, stable air sinking down from way up in the atmosphere. That sinking air actually stops clouds from forming, creating this moment of calm right in the middle of absolute chaos.
For all the talk about wind and rain, that's not even the deadliest part of a tropical storm. Nope. The biggest threat, the thing that causes the most damage, is actually a hidden danger that comes from the ocean itself.
It's called a storm surge. And listen, this isn't just a big wave. The storm's super low pressure and its powerful winds literally pile up the ocean water. They create this huge bulge of water that gets pushed towards the coast.
It's like a wall of seawater, and it often hits before the worst of the storm even arrives.
And how big a wall are we talking? Well, it can be immense. We're talking up to 5 meters high. That is higher than a double-decker bus. And that's why it's the surge, and not the wind, that's responsible for the most widespread and deadly flooding in coastal areas.
Okay, so now we get how these storms are built, right? We know the recipe. But the rules of the game are changing. A warming planet is directly messing with that recipe we just talked about, and it's basically supercharging these natural events. So that leads us to the really crucial question, doesn't it? What does all this actually mean for the storms we're going to see in the future?
Well, the science is pointing to a few key things. First, rising sea levels are giving those storm surges a head start, a higher launch pad, which pushes that deadly flooding even further inland. Second, the storms themselves are getting stronger. Warmer oceans mean more fuel, which means more intense winds and a lot more rain. And finally, we might even start seeing more storms forming in general, maybe even in places where they haven't really been a problem before.
And it's interesting, part of that sea level rise isn't even about melting ice. It's something called thermal expansion. And the idea is really simple. When water gets warmer, it expands. It takes up more space. It's just like when you boil a pan of water on the stove and the water level goes up. Well, that's what's happening in our oceans.
And look, this isn't some far-off, distant threat. In just the last 100 years, the average sea surface temperature has already gone up by 1.3 degrees Celsius. The fuel tank for these massive storms, it's already getting warmer.
So you put it all together, stronger winds, way more rain, and higher, more dangerous storm surges. And it all leads us to one final, really critical question. We know what's coming. We understand the science behind it. But knowing everything we know, are our coasts truly ready for the storms of tomorrow?